The smell hit Colonel Ernst Meisel before the sound did. Standing on the concrete apron of the Cherbourg rail yards on the 14th of July 1944, 31 days after the Allied landings, he caught diesel exhaust and hot iron and something else. A mechanical presence, a weight in the air, before he turned and saw what his intelligence reports had failed, in any meaningful way, to prepare him for. What he saw was a locomotive, a whole one, complete, intact, fully assembled, swinging from the hook of a harbour crane at a height of approximately 40 feet above the quayside, its driving wheels still turning slightly from the momentum of the lift, its cab painted in a flat olive drab that had already begun to chalk in the Norman salt air. The crane set it down. The sound it made when the wheels touched the rail was a single low concussion, like an artillery piece fired at distance. Then it was just standing there on French track, breathing steam, as if it had always been there, as if it had grown up from the ballast. Meisel was a railroad man before he was a soldier. He had spent 19 years with the Reichsbahn, the last 4 in a uniform that made his railroad expertise a military asset, and he understood, in the cellular way that professional experience becomes understanding, what it meant to move a locomotive from one rail network to another. You disassemble it, you crate the major components separately, you ship them in sequence, and you reassemble on the other end, which takes time, skilled labour, specialised tooling, and a facility capable of handling the work. That was the process. That was what the process had always been. He watched a second locomotive come off the ship, then a third. What the Americans were doing was not possible, and yet there was no alternative word for what he was watching except possible, because it was happening in front of him on a Tuesday morning with seagulls overhead and French dock workers guiding the crane lines with boat hooks, and a young American lieutenant eating a sandwich on a timber bit with the bored expression of a man watching a process he has seen enough times to find unremarkable. The question Meisel wrote in his field notebook that afternoon, in the precise, abbreviated hand of a man trained to produce reports rather than literature, was not a dramatic one. It was technical, almost administrative in its phrasing. He wanted to know how many of these locomotives existed. Not how many had arrived, how many existed, in total, waiting in American yards to make the same crossing, to come ashore the same way, to stand up on French track and begin moving supplies toward a front line that was, at that moment, still less than 40 miles away. Nobody gave him a satisfactory answer. He may not have wanted one. Part 1. The Railroad as Infrastructure of Empire. There is a fact about American railroads that most people encounter as a statistic and immediately forget, because it is too large to hold in the mind comfortably. In 1943, the United States operated approximately 233,000 miles of mainline railroad track. That number requires some unpacking. All of Europe combined, including the Soviet Union west of the Ural Mountains, operated roughly 175,000 miles. The United States had more railroad than an entire continent. This was not an accident of geography. It was a deliberate, aggressive, often violent project of national construction that had been underway since 1830 and had not really stopped. The Transcontinental Railroad was completed in 1869. By 1890, there were 4 separate transcontinental routes. By 1900, American railroads employed more than 1 million men, more workers than the entire German army at its peacetime strength. The consequence of this scale was institutional. By the time the Second World War began, American railroads had developed a logistics culture that operated at a level of complexity and coordination that had no equivalent anywhere else in the world. Think about what it means to run a railroad that spans a continent. You cannot manage it from one office. You cannot inspect it from one location. You cannot fix a problem in Montana by sending a man from New York. You need distributed competence, local managers who can make decisions, local repair shops that can fabricate parts, local procurement officers who understand what their section of track needs and can get it without waiting for authorization from headquarters. This is not the German system. The German system, the Reichsbahn, was centralized, hierarchical, and extraordinarily efficient within its own geography. It was designed to move men and materiel across Central Europe with precision and speed, and for that purpose it worked magnificently. What it was not designed to do was improvise. It was not designed to function when the central hierarchy was disrupted, when the supply chain was bombed, when the track was cut in 100 places simultaneously. The American system was designed for exactly that, because that was what building a transcontinental railroad in the 19th century required. The men who built the Union Pacific and the Central Pacific were not working with established infrastructure. They were building into empty space, constantly ahead of their supply line. Constantly improvising. The institutional memory of American railroading was a memory of construction under impossible conditions. And here is the key detail that made 1944 possible. In 1942, the War Department established the Military Railway Service, the MRS. This was not simply an administrative unit, it was a deliberate mobilization of the entire institutional knowledge of American railroading, uniformed and deployed as a military force. The officers of the MRS were not career soldiers who had been taught about railroads. They were railroadmen, presidents of divisions, chief engineers, master mechanics, train masters, who had been given military rank and sent to do what they already knew how to do. Meet Colonel Carl R. Gray, Jr., 48 years old in 1943, born in Sioux City, Iowa. Before the war, president of the Chicago and Northwestern Railway, commissioned as a brigadier general and appointed director of the Military Railway Service in the European theatre. He had spent 30 years managing one of the largest railroad systems in the Midwest. He understood track gauge, locomotive maintenance, car distribution, bridge load limits, and personnel management at a scale that most military officers could not conceptualize. He was not a soldier who had learned about logistics. He was a logistics system that had been given a uniform. The MRS eventually operated 37 railway operating battalions and 17 railway shop battalions in the European theatre. Each battalion was staffed by men who had worked for actual American railroads, the Pennsylvania, the Baltimore and Ohio, the Southern Pacific, the Union Pacific. When they needed to repair a locomotive in France, they were not consulting manuals. They were doing what they had done in peacetime, with the same tools, in a different country. This institutional depth is what the German railway officers, reviewing their intelligence reports in the autumn of 1944, could not account for. They understood the Wehrmacht's logistics system, which was centralized and dependent on intact infrastructure. They did not understand a system that had been built from the beginning to function without intact infrastructure, because in America there had never been intact infrastructure to begin with. Part 2. The problem of the ocean. Hold this number in your mind for a moment. An American standard freight locomotive of the type used in Europe, specifically the United States Army Transportation Corps S-160 class, weighed approximately 158,000 pounds. That is 71 metric tons. It was 48 feet long, it stood 15 feet tall, the driving wheels alone were 63 inches in diameter. Now think about what it means to put that object on a ship. The Liberty ship, which was the standard American cargo vessel of the war, had a cargo capacity of roughly 10,900 tons. That sounds like a lot until you realize that a single S-160 locomotive represented approximately 0.7% of that capacity by weight, and considerably more than that by volume and by the complexity of the loading operation required. You could not simply stack locomotives in a hold the way you stacked crates of ammunition. Each one had to be individually secured, braced against the motion of the sea, protected from saltwater corrosion, and arranged so that it could be unloaded at the other end without destroying the ship in the process. The solution was to partially disassemble the locomotives before loading. The running boards were removed. The cab was sometimes taken off. The smoke box door and certain external fittings were stowed separately. This reduced the height enough to fit through the hatch of a Liberty ship hold, though only barely. The locomotive was then lowered in by crane, resting on a cradle of timber, and secured with chains and bracing. The process of loading a single locomotive took approximately 4 hours with an experienced crew. The process of unloading it at the other end took roughly the same. But unloading at Cherbourg in the summer of 1944 was not a matter of using a convenient dockside crane, because the dockside cranes had been destroyed. This is where the American operation becomes genuinely remarkable. The Army had anticipated this problem before the invasion. The solution was the floating crane, specifically the barge derrick, the BD series vessels that the Army Corps of Engineers had commissioned and deployed specifically for the purpose of port reconstruction in a destroyed harbour. The BD series cranes had a lifting capacity of 150 tons, which was sufficient to lift a fully assembled locomotive directly from a ship's hold. They were self-propelled, which meant they could manoeuvre in a harbour without depending on shore-based infrastructure. And they were American-built, which meant the men operating them had been trained on American equipment by American instructors. Let that settle for a moment. The Americans had built cranes specifically designed to lift locomotives out of ships in harbours where the cranes had been destroyed. They had built these cranes before the invasion, on the assumption that the Germans would destroy the port facilities, because the Germans always destroyed the port facilities. This was not improvisation. This was pre-planned industrial logistics at a scale and specificity that the German Wehrmacht, fighting a war of improvisation and resource scarcity, simply had no framework to understand. Meet Technical Sergeant Raymond J. Kowalski, 26 years old, from Hamtramck, Michigan, the Polish-American working-class suburb of Detroit, where his father had worked at the Dodge main plant since 1922. Before the Army, Raymond had worked 3 years as a crane operator at the River Rouge complex. He knew how to move heavy metal. He was assigned to the 549th Engineer Heavy Ponton Battalion, which was not actually a ponton unit but had been redesignated for port reconstruction work. He spent the summer of 1944 operating a floating crane in Cherbourg Harbour, lifting locomotives out of Liberty ships and setting them on the dock. He did not leave a memoir. He left a single letter home dated August 8, 1944, which his family preserved and which was later donated to the Michigan Historical Collections at the University of Michigan. In it, he wrote to his mother that his job was like picking up toy trains and putting them down on the tracks, except the toys weigh as much as a house, and if you drop one, you have a very bad day. That letter, written by a 26-year-old crane operator from Hamtramck, contains more operational clarity than most official reports on the subject. The first American locomotives arrived at Cherbourg in July of 1944. The exact date is disputed in the records, different units claim different firsts, but the consensus among historians of the military railway service is that the first S160 to operate under its own power on French rails did so in the 3rd week of July, approximately 3 weeks after the port fell. By the end of August, there were over 200 American locomotives operating in France. By October, the number exceeded 500. Think about what that means. 500 locomotives, each weighing 71 tons, each manufactured in the United States, each shipped across the Atlantic, each lifted by floating crane out of a destroyed harbour. The total weight of locomotives alone exceeded 35,000 tons. And locomotives were only the beginning. The Americans also shipped flat cars, box cars, gondola cars, tank cars, and hopper cars by the thousands. They shipped rail in standard American lengths. They shipped ties, spikes, fish plates, and switch components. They shipped roundhouse equipment, machine tools, and spare parts. They shipped fuel oil and water treatment chemicals for the locomotive boilers. They shipped everything necessary to operate a railroad system because the railroad system they intended to operate did not exist in France. The German railway officers who received the intelligence reports about this were confronting something outside their professional experience. In their world, you operated the railroad that was there. You repaired it, you extended it, you exploited it, but it was always there. It was always the foundation. The idea that you could simply manufacture a railroad in another country and ship it across an ocean was not a concept that had a place in German operational planning. It was not that they thought it was impossible, it was that the thought had not occurred to them to think about it at all. And while they were not thinking about it, it was happening. Part 3. The machine arrives. The S160 class locomotive was not the finest locomotive American engineers had ever built. It was not designed for beauty or for speed. It was designed for one specific purpose: to operate on the mixed-gauge, war-damaged, poorly maintained railroads of a liberated European country, with minimum maintenance requirements by crews who might have little experience with that specific model. The specifications are worth examining in detail because they reveal the nature of the thinking behind them. The S160 was a 280 steam locomotive, meaning it had 2 leading wheels, 8 driving wheels, and no trailing wheels. It was built to the standard gauge of 4 feet 8.5 inches, which was the common gauge of most European railroads, so it could operate on French, Belgian, British, and German track without modification. The boiler pressure was 225 pounds per square inch. The tractive effort, the pulling force at the drawbar, was 31,500 pounds. It could haul a loaded freight train of approximately 1,000 tons on level track. But the design choices that matter most are not the performance figures. They are the maintenance figures. The S160 was designed with accessibility in mind. Every component that required regular service was positioned so that a mechanic could reach it without specialized equipment. The valve gear, the mechanism that controlled the timing of steam admission to the cylinders, was a simplified version of the Walschaerts design that American locomotive mechanics had been using since the turn of the century. The lubricators were self-contained and easily refilled. The boiler washout plugs, used to remove scale buildup from the boiler, were positioned at regular intervals around the boiler barrel, accessible from track level. The locomotive was, in the language of its designers at the American Locomotive Company in Schenectady, New York, field maintainable. That phrase conceals an enormous amount of engineering work. Making something field maintainable means anticipating every way it can fail, and then designing the failure mode to be fixable with tools a field unit would have. It means accepting performance compromises in exchange for reliability. It means building something that is slightly less good when everything is working, but dramatically better when everything is not working. The Germans built magnificent locomotives. The BR-52 war locomotive, the Kriegslokomotive, was a masterpiece of rational engineering, stripped of everything non-essential, optimized for production speed and fuel efficiency. It was also, under combat conditions, difficult to maintain. It required trained mechanics. It required specific spare parts. It required, in short, the kind of industrial support system that was becoming unavailable to Germany by 1944. Here is the most brutal irony of the comparison. The BR-52 was designed to be simple to produce. The S160 was designed to be simple to maintain. These are not the same thing. The Germans optimized for the factory. The Americans optimized for the field. And by the time the locomotives were actually running in France, the factory was irrelevant, and the field was everything. Now stop and consider what this meant on the ground. In the autumn of 1944, the Allied advance from Normandy to the German border had outrun its supply lines. This is well documented, and it is the reason the advance stalled in September. The immediate cause of the supply crisis was not a shortage of materiel. There was plenty of materiel at the ports. The cause was transportation. There was not enough truck capacity to move supplies from the ports to the front. The Red Ball Express, the improvised truck convoy system, was moving approximately 12,500 tons per day, but the front needed 18,000 tons per day to sustain offensive operations. The railroad was the answer. A single train could move what 100 trucks could move, using a fraction of the fuel operated by a fraction of the personnel. The military railway service's task was to get trains running from Cherbourg to the front as fast as possible. This is where the pre-positioned locomotives became decisive. A truck convoy required trucks, drivers, fuel, maintenance, and road surface, all of which were being consumed by the combat operations they were supposed to support. A locomotive required track, fuel, water, and a crew of 3. The track was being repaired by engineer battalions at a rate that, in some stretches, exceeded a mile per day. The fuel was being shipped. The water was available from French wells and rivers. The crews were the railroaders of the military railway service, who knew exactly what they were doing. Meet Captain William A. Becker, 31 years old, from Altoona, Pennsylvania, which is not an incidental detail. Altoona was the headquarters of the Pennsylvania Railroad's mechanical department, the largest locomotive repair facility in the world. His father had worked at the Altoona shops. His uncle had worked at the Altoona shops. William himself had been a locomotive engineer on the Pennsyl's main line before his commission, running the Broadway Limited between New York and Chicago. He was now commanding a company of the 713th Railway Operating Battalion, assigned to operate trains between Cherbourg and the railhead at Longuyon, approximately 400 miles to the east. The route was not pleasant. The track had been bombed by the Allied air forces before the invasion, bombed again during the breakout, and was being repaired by engineer battalions working ahead of the trains. There were bridges out, replaced by temporary timber trestles that vibrated alarmingly under a loaded train. There were stretches where the track alignment was off by enough that the locomotive swayed and the crew watched the speedometer and said nothing to each other. There were signals that did not work, sidings that were blocked by wreckage, and grade crossings where the road surface had been destroyed and the locomotive had to slow to walking pace. Becker ran the route anyway. His crew ran it. The other crews of the 713th ran it. They ran it because that was what they had been sent to do, and because they were railroad men, and railroad men ran the route. In September of 1944, the military railway service moved approximately 500,000 tons of supplies over French and Belgian railroads. In October, the figure rose to 700,000 tons. By December, it exceeded 1 million tons per month. Those numbers were not achieved by the Red Ball Express trucks, which were wearing out their vehicles and their drivers at a rate that alarmed the Transportation Corps. They were achieved by the S-160 locomotives that had been lifted out of the harbour at Cherbourg by floating cranes set on French rails and driven east by men from Altoona and Sioux City and Hamtramck. And here is what the captured Wehrmacht logistics colonel had not been told or had not believed when he received his first intelligence reports. This was all planned. Every locomotive, every floating crane, every railway operating battalion, every spare part. The entire operation had been designed in Washington and in London in 1942 and 1943 before a single American soldier had set foot on French soil. The Transportation Corps had calculated how many locomotives would be needed, what type they should be, how they would be shipped, how they would be unloaded in a destroyed harbour, how they would be maintained in the field, and how they would be crewed. They had placed orders with Baldwin Locomotive Works in Eddystone, Pennsylvania, and with the American Locomotive Company in Schenectady, New York, for the specific quantity required. They had commissioned the floating cranes. They had organized the military railway service battalions. They had done all of this before the war in France had begun. The German system was reactive. It responded to events as they occurred, improvising solutions to problems as they appeared. The American system was predictive. It anticipated problems before they occurred and built the solutions in advance. This was not a moral difference. It was a structural difference, rooted in the different histories of the two industrial systems. The Germans built the best railroad in Europe. The Americans built a railroad they could take with them. There is a difference. Now the most important part, Part 4, the verdict. Here is the forensic verdict of this investigation. The story of the American locomotives at Cherbourg is not, at its core, a story about locomotives. It is a story about the difference between two kinds of industrial competence, one that optimizes for a known environment and one that optimizes for an unknown one. The German Reichsbahn was, by any objective measure, a superior railroad to anything the Americans operated. It ran on time with a precision that American railroaders found almost theatrical. Its locomotives were better engineered, its track maintenance was more systematic, its operating procedures were more refined. In Germany, on German track, with German support infrastructure, the Reichsbahn performed at a level the American railroads could not match. But the Reichsbahn had been built for Germany. It had been built for a specific geography, a specific climate, a specific set of operational demands. When those conditions changed, when the track was bombed, when the bridges were out, when the maintenance shops were destroyed, when the spare parts were unavailable, the system that had been optimized for normal conditions had no reserve capacity for abnormal ones. The American military railway service had been built for France, not for France specifically, for anywhere that was not America, anywhere that might be destroyed, anywhere that the infrastructure might not exist. This was the institutional memory of the transcontinental railroads, the memory of building into empty space applied to the problem of European warfare. Stop and think about that for a moment. The men who built the Union Pacific across the Great Plains in the 1860s were not thinking about the Second World War. They were not thinking about France. They were thinking about the next 100 miles of empty territory and how to lay track through it and how to keep the locomotives running without a repair shop within 500 miles. But the habits of mind they developed, the distributed competence, the field maintainable equipment, the institutional tolerance for improvisation, those habits survived. They survived in the culture of the American railroads, in the training of American mechanics and engineers and trainmasters, in the design philosophy of American locomotive builders. And when the War Department mobilized the Military Railway Service in 1942, it mobilized those habits along with the men who carried them. The German railway officers who could not believe the intelligence reports were not stupid. They were not incompetent. They were men who had spent their careers in a system that did not need to think about this problem, and therefore had not thought about it. Now consider the numbers one final time. By the end of 1944, the United States Army had shipped 1,981 S-160 class locomotives to Europe. Each one weighed 71 tons. Each one was manufactured in the United States, shipped across the Atlantic, and unloaded in a harbor where the cranes had been destroyed. The total weight of locomotives alone was approximately 140,000 tons. The total tonnage of all railway equipment shipped, locomotives, cars, track materials, maintenance supplies, exceeded 4 million tons. 4 million tons of railroad shipped across an ocean. Soak in that figure. The entire logistical effort of the German army on the Eastern Front in 1941, the largest military operation in history, moved approximately 500,000 tons of supplies in the first month of the campaign. The Americans moved 4 million tons of railroad infrastructure across an ocean, in addition to everything else they were shipping. This was not a miracle of production. American production was extraordinary, but production alone does not explain what happened at Cherbourg. What explains it is the prior decision, made years before the invasion, made in offices in Washington and in the boardrooms of Baldwin and Alco and the Pennsylvania Railroad, to build a system that could be taken apart, put on ships, and reassembled somewhere else. That decision required a particular way of thinking about infrastructure, not as something fixed and permanent, but as something portable and provisional. The Germans thought of their railroad as Germany's railroad. The Americans thought of their railroad as a tool. Let us return to Colonel Haynes W. Dunn, standing in the ruined rail yard at Cherbourg on the first day of American occupation, writing in his field log that the enemy has been thorough. He was right. The enemy had been thorough. They had destroyed every locomotive, every turntable, every roundhouse, every significant piece of infrastructure in the yard. They had done exactly what they intended to do, and it had not mattered. It had not mattered because Dunn knew, standing in that ruined yard, that the locomotives were already on their way. They were on Liberty ships in the Atlantic, packed in timber cradles, their cabs removed to fit through the hatches, their boilers drained and sealed against the salt air. They were coming. The floating cranes to unload them were already in the harbour. The The railway operating battalions to crew them were already in England, waiting for the port to be ready. The Germans had destroyed the railroad. The Americans had brought a new one. Dunn would later write, in a report to the Transportation Corps dated October of 1944, that the speed of the recovery at Cherbourg had exceeded all planning estimates. The first locomotive was operating in 3 weeks. The first through train to Paris ran in approximately 6 weeks. Within 90 days of the port's capture, the military railway service was moving more tonnage per day through Cherbourg than the original French railroad system had moved in peacetime. The enemy had been thorough. It had not been enough. Raymond Kowalski, the crane operator from Hamtramck who had compared lifting locomotives to playing with toy trains, served in France through the winter of 1944 and into the spring of 1945. He was discharged in September of 1945 and returned to Michigan, where he went back to crane work, eventually becoming a foreman at a Detroit area steel fabrication plant. He died in 1987 at the age of 69. He is buried at Woodmere Cemetery in Detroit. William Becker, the locomotive engineer from Altoona who ran the route between Cherbourg and Longuyon on track that vibrated alarmingly, received the Bronze Star for his service with the 713th Railway Operating Battalion. He returned to the Pennsylvania Railroad after the war and spent another 20 years running trains on the main line. He retired in 1966. He died in 1979 at the age of 66. Carl Gray, the president of the Chicago and Northwestern, who became the director of the Military Railway Service, was awarded the Distinguished Service Medal. He returned to civilian railroad management after the war and died in 1953 at the age of 58. The citation for his medal noted that he had organized and directed the operation of military railways in a theater of war with the same professional competence he had applied to the operation of civilian railroads in peacetime. That sentence, written by a military bureaucrat in Washington, is actually a precise description of what made the whole operation work. It was the same competence, applied in a different place, to a problem that had been anticipated years in advance. The captured Wehrmacht logistics colonel, who had refused to believe the first intelligence reports about American locomotives being craned ashore at Cherbourg, was eventually shown photographs. He looked at them for a long time. Then he said, and this is documented in the Theatre Service Force's European Theatre records, that he now understood what he had not understood before. He said, "You did not improvise this, you planned it." He was right, they had planned it, and that, in the end, is the only thing that needs to be said about why the Germans couldn't believe what was happening at Cherbourg and why it happened anyway, precisely on schedule, exactly as designed, by men who had spent their careers learning to move things across impossible distances and who had simply been asked, this time, to move them across an ocean. The railroad came ashore. It had always been coming.